Hello everyone, welcome to Prime Mathematics. Today I am going to discuss the 2025 paper 1 problem, which is given as let alpha and beta be real numbers such that this equation is being satisfied by these alpha and beta, and we need to find the values of these alpha and beta. That's our main objective. So first, if we try to make it a proper fractional form, we get limit x tending to 0 alpha by 2 0 to x dt upon 1 minus t square, then plus beta x cos x, and in the denominator section we have x cube. This value is equals to 2, right? So if we apply LH rule, because we observed that the numerator is going to 0 and denominator is also going to 0 when we put x as 0, so one can just simply do L'Hospital rule, which is the differentiation of numerator as well as denominator. So differentiation of dt by 1 minus t square integration 0 to x via the Newton-Leibniz integral, it will be 1 upon 1 minus x square. And similarly, if we differentiate this via product rule, so first into differentiation of second will be minus sin x, second into differentiation of first will be 1, and the denominator, if we differentiate x cube, we get 3x square, and the limit is 2. Now we know a little bit approximation, that via approximation what we can do, 1 upon 1 minus x square can be written as 1 minus x square to the power negative 1, and approximately it is 1 plus x square, since 1 plus x whole to the power n, where n belongs to integer, it can be written as approximately 1 plus nx, right? So using this criteria, we have this approximation first. Second approximation will use that whenever x tends to 0, sin x can be approximately written as x. Third approximation, whenever x tends to 0, cos x can be approximately written as 1 minus x square by 2. So using this, in the upper part we get limit x tending to 0 alpha by 2, 1 upon 1 minus x square can be written as 1 plus x square, right? Then we have beta multiply with sin x can be written as x, so it will be x into minus x, which is negative x square. Cos x value would be 1 minus x square by 2. If we simplify this term, so minus x square by 2 minus x square will provide as minus 3x square by 2. So after simplification, we can write as 1 minus 3x square by 2. In the denominator section, we have as it is 3x square. Now if we put x0 in the numerator section, we observe that the limit goes to alpha by 2 plus beta, and denominator section it goes to 0. So alpha by 2 plus beta should be 0 for the existence of limit, because in case if it is non-zero, then limit won't exist. So when alpha by 2 plus beta is 0, then you get beta as minus alpha by 2, or one can simply write it as alpha by 2 as minus of beta, right? So alpha by 2 will come out to be as minus beta. Now using this in this equation, we get limit x tending to 0. In replacement of alpha by 2, one can write it as minus beta 1 plus x square plus beta 1 minus 3x square by 2, right? And denominator we have 3x square, which is equals to 2. So now one can take beta common. So if we take beta common, we get what? we get 1 minus 3x square by 2 minus 1 minus x square, right? In the denominator, we have 3x square. Now, if you observe, this 1 gets cancelled out. Minus 3x square by 2 minus x square will come out to be as minus 5x square by 2 dot beta divided by 3x square, and the limit is going to x tending to 0. So if we observe very much carefully, we get x square cancel out. So minus 5 by 6 times of beta, this will be the limit, and that will be itself equal to, because we already mentioned the limit. So beta will come out to be as, I think, minus 12 by 5. Is it so? Now, as we know that alpha by 2 is minus of beta, it means alpha can be written as minus twice of beta. So minus 2 into beta is minus 12 by 5. So you get 24 by 5. Now it is asking the value of alpha plus beta. So alpha plus beta will be 24 by 5. That is the value of alpha. And beta value is minus 12 by 5. So you get, I think, 12 by 5, right? And 12 by 5 is in decimal, I think, 2.40. So that's your answer. Thank you, everyone.